Dear students, ഇന്ന് നമ്മൾ പഠിക്കുന്നത് എന്താണ് എനർജി ഫ്ലക്സ് അല്ലെങ്കിൽ എനർജി കറന്റ്, എന്താണ് ഇന്റൻസിറ്റി ഓഫ് എ വേവ്. എനർജി കറന്റ് ഓർ എനർജി ഫ്ലക്സ് എന്ന് പറഞ്ഞാൽ ഒരു വേവ് ഫ്രണ്ടിന്റെ യൂണിറ്റ് ഏരിയയ്ക്ക് അക്രോസ് ആയിട്ട് യൂണിറ്റ് ടൈമിൽ ട്രാൻസ്ഫർ ചെയ്യുന്ന എനർജിയാണ്. അല്ലെങ്കിൽ ഒരു വേവ് ഫ്രണ്ടിന്റെ യൂണിറ്റ് ഏരിയയ്ക്ക് അക്രോസ് ആയിട്ട് ട്രാൻസ്ഫർ ചെയ്യുന്ന എനർജിയുടെ റേറ്റിനെയാണ് എനർജി ഫ്ലക്സ് അല്ലെങ്കിൽ എനർജി കറന്റ് എന്ന് പറയുന്നത്. ദാറ്റ് ഈസ് the rate of transmission of energy across unit area of a wavefront is called the energy flux or energy current. ഈ എനർജി ഫ്ലക്സിന് അല്ലെങ്കിൽ എനർജി കറന്റിന് എനർജി ഡെൻസിറ്റിയുടെയും വേവ് വെലോസിറ്റിയുടെയും പ്രോഡക്റ്റ് ആയിട്ട് റെപ്രസെന്റ് ചെയ്യാം. If V is the wave velocity, then the energy current or energy flux can be represented as the energy density into the wave velocity. That is, it can be represented as the product of energy density and wave velocity. That is, we have already studied energy density as 2 pi square a square n square rho. Then the energy current is 2 pi square a square n square rho into V. That is energy current. That is, energy current or energy flux can be defined as the rate of transmission of energy across unit area of a wavefront, and it can be represented as the product of energy density and wave velocity. Next is the intensity of a wave. The intensity of a wave can be defined as the total energy of the wave passing through unit area in unit time. That is, intensity means unit ഏരിയയ്ക്ക് അക്രോസ് ആയിട്ട് യൂണിറ്റ് ടൈമിൽ പാസ് ചെയ്യുന്ന ടോട്ടൽ എനർജിയാണ്. ദാറ്റ് ഈസ്, ഒരു യൂണിറ്റ് ഏരിയയിലൂടെ യൂണിറ്റ് ടൈമിൽ പാസ് ചെയ്യുന്ന ടോട്ടൽ എനർജിയാണ് ഇന്റൻസിറ്റി എന്ന് പറയുന്നത്. ഈ ഇന്റൻസിറ്റി എനർജി കറന്റിന് ഇക്വലന്റ് ആണ്. ദാറ്റ് ഈസ്, ഇന്റൻസിറ്റി ക്യാൻ ബി റെപ്രസെന്റഡ് ആസ് I is equal to total energy by area into time. That is, intensity means the total energy per unit area per unit time. That is, total energy divided by area into time. ഈ ഇക്വേഷന് ന്യൂമറേറ്ററിനെയും ഡിനോമിനേറ്ററിനെയും ലെങ്ത് കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്യുന്നു. അതായത് ഇന്റൻസിറ്റി ഈസ് ഈക്വൽ ടു ടോട്ടൽ എനർജി ഇൻറ്റു ലെങ്ത് ഡിവൈഡഡ് ബൈ ഏരിയ ഇൻറ്റു ലെങ്ത് ഇൻറ്റു ടൈം. ദെൻ ഈ ഏരിയ ഇൻറ്റു ലെങ്ത് മീൻസ് ഇറ്റ് ഈസ് വോളിയം. ദാറ്റ് ഈസ്, area into length is volume. Therefore, intensity I is equal to total energy into length divided by volume into time. That is, this length by time is the velocity. Therefore, the intensity I is equal to total energy into velocity divided by volume. Then total energy divided by volume is the total energy density. That is, intensity I is equal to total energy density into wave velocity. That is, total energy is equal to energy current. That is, intensity of a wave can be defined as the total energy of the wave passing through unit cross-sectional area in unit time, and it is equal to the energy current. That is, intensity is equal to total energy density into velocity. Unit of the intensity is watt per meter square, or it can be represented as joule per meter square second. Joule by second is watt. Intensity of wave and spherical waves. Intensity of a wave is defined as the amount of incident energy per unit area per unit time. In the case of plane wavefront, the amplitude and hence the intensity do not changes with distance. Amplitude and intensity are related because intensity will be proportional to the square of the amplitude. And consider a point source emitting spherical waves, and let W be the energy emitted per unit time, and assume this as a point source, and this point source, it produces spherical waves. because the wavefront will be spherical one. And let W be the energy emitted per unit time from the source. And assuming this point source as a center, and imagine a spherical surface. This point is taken as the center of a sphere, and then the energy emitted from this point source, it will spread into this spherical surface. And let R be the radius of the sphere. Then the surface area of the sphere will be 4 pi r square. Therefore, the intensity of the wave on the surface of the sphere is, I can be represented as intensity is equal to, intensity means the energy per unit area per unit time. That is, the energy per unit time is W. W means it's the energy per unit time. Therefore, W and divided by the area will be 4 pi r square. Therefore, intensity is W by 4 pi r square. That is the energy per unit time per unit area. The energy per unit time is W and the area will be 4 pi r square. That is, consider a point source, and with this point source it emits spherical waves, and consider a spherical surface with the point source as at the center. ഒരു സ്ഫിയറിന്റെ സെൻട്രൽ ഈ പോയിന്റ് സോഴ്സ് ഇരിക്കുകയാണ്. അങ്ങനെയാണെങ്കിൽ ഈ പോയിന്റ് സോഴ്സ് എമിറ്റ് ചെയ്യുന്ന റേഡിയേഷൻ ആ സ്ഫെറിക്കൽ സർഫസിൽ സ്പ്രെഡ് ചെയ്യുന്നു. അങ്ങനെയാണെങ്കിൽ ആ സ്ഫിയറിന്റെ സർഫസിലെ വേവ് ഇന്റൻസിറ്റി I is equal to W by 4 pi r square എന്ന ഇക്വേഷൻ കൊണ്ട് റെപ്രസെന്റ് ചെയ്യാം. Here the intensity and R are related by the relation I will be proportional to 1 by r square. Intensity and R are inversely related. Therefore, the intensity will be proportional to 1 by r square and the intensity will be proportional to amplitude square. Then intensity 1 by r square dependence ആണ് ഡിസ്റ്റൻസിന്. അങ്ങനെയാണെങ്കിൽ ആംപ്ലിറ്റ്യൂഡിന്റെ ഡിപെൻഡൻസ് 1 by r ആയിരിക്കും. കാരണം intensity will be proportional to 1 by r square. Then amplitude will be proportional to 1 by r. Because intensity and amplitude are related by intensity will be proportional to amplitude square. Therefore, A will be proportional to 1 by r, or proportionality sign മാറ്റി ഒരു കോൺസ്റ്റന്റ് എടുക്കുന്നു. That is A is equal to a constant A divided by r. That is the amplitude will be amplitude can be written as A by r where A is a constant. That is A is equal to A by r where A is a constant. Hence, the equation of a spherical wave is given as, that we have studied the equation of a spherical wave as y is equal to A sin 2 pi by lambda Vt minus x. Here, the A amplitude can be represented in terms of the distance. Therefore, A can be written as A divided by r. That is, y is equal to A by r into sin 2 pi by lambda into Vt minus x. That is, the equation of a spherical wave is given by y is equal to A by r into sin 2 pi by lambda Vt minus x. That is, the spherical wave r നെ ഡിപെൻഡ് ചെയ്യുന്നു. സ്ഫെറിക്കൽ വേവിന്റെ ആംപ്ലിറ്റ്യൂഡ് r നെ ഡിപെൻഡ് ചെയ്യുന്നു. Next is a problem. A radio station having a source 10⁵ watt power is transmitting radio waves. If the speed of the radio waves is 3 into 10⁸ meter per second, find the energy density at a distance 5 into 10⁵ meter. Assume the medium to be isotropic and non-dissipating. That is, in the equation, a radio station is emitting radio waves and the power is 10⁵ watt. The speed of the radio waves is 3 into 10⁸ meter per second. It is an electromagnetic wave. Then the energy density at a distance 5 into 10⁵, and the medium is isotropic. That is, the property will be the same in all directions. That is isotropic. If you are considering the velocity, then it will be same in all directions. From the data given, the power given is, that is, the W is given as 10⁵ watt, and the velocity, wave velocity, radio wave velocity is 3 into 10⁸ meter per second. And the distance r as 5 into 10⁵ meter. That is, the W is equal to 10 raised to 5 watt and V is equal to 3 into 10 raised to 8 meter per second and R is 5 into 10 raised to 5 meter. And then we have the equation, that is intensity is equal to W divided by 4 pi R square. That is intensity is equal to W by 4 pi R square. And given W is equal to 10 raised to 5 and the R is given, that is 4 into 3.14 into R square is 5 into 10 raised to 5 the whole square. The intensity is given, that is we have to find out the energy density. That is, the energy density and the intensity are related by a relation. That is, we have studied that the intensity of a wave is equal to the energy density into the wave velocity. Therefore, the energy density is equal to the intensity divided by wave velocity. And the intensity is given as I is equal to W by 4 pi R square, that is 10 raised to 5 divided by 4 into 3.14 into 5 into 10 raised to 5 the whole square divided by wave velocity, that is into 3 into 10 raised to 8. And the final value will be, you should find out the final value, that is 1.06 into 10 raised to minus 16 and the unit is joule, that is energy density. Energy density means energy by volume, joule energy by meter cube. That is, this is the final equation and you should check whether it is correct. The final value will be correct or not. That is 1.06 into 10 raised to minus 16 joule per meter cube. That is the energy density.